Yeah, so now let's come to spermatogenesis. Spermatogenesis is a very important topic that comes in all exams. Spermatogenesis as well as oogenesis, both spermatogenesis and oogenesis comes in very well in all types of exams. So first we'll see the first point. The first point reads: primordial germ cells enter testis and become spermatogonia. So this is the typical yolk sac. This is the yolk sac. This is the yolk sac, and here primordial germ cell enter the testes. So this comes in embryology part. It's not very much required, but okay. Primordial germ cells enters testis and become the spermatogonia. Remember, spermatogonia is 2n, that is, it is diploid. Spermatogonia is always diploid. Spermatogonia is diploid. This is the basal surface. This basal surface is spermatogonium. This is the basal surface is Sertoli cells. The two types of cells. This is the Sertoli is spermatogonium. This is the spermatogonium. This is the basal surface. This is the basal surface. Basal surface. This is the Sertoli cells. Now, before coming to this diagram, let's come here. Here we have the diagram that shows this is the seminiferous tubule. This is the seminiferous tubule. Seminiferous tubule. Then comes the rete testis. This is the rete testis. Rete testis. This is the rete testis. So from the seminiferous tubule we have the rete testis. These are the rete testis. They are coming, and then they are forming the they coil here. They coil here. This is the head of epididymis. This is called the head of epididymis. Then this is the tail. This is the tail of epididymis. So arising from the rete testis, from seminiferous tubule we have the, so after seminiferous tubule rete testis, then comes head of epididymis, then comes the tail of epididymis, and then they join to form the vas deferens, and then the vas deferens ultimately opens into the ejaculatory duct. Ejaculatory duct. It finally opens into ejaculatory duct. Okay. Now coming here, this is spermatogonia. This is spermatogonia. The spermatogonia regenerates. So this spermatogonia gives two types of cells. One is B cell, one is A cell. Among B and A cell, the A cell regenerates again into the spermatogonia. The A cell again regenerates into spermatogonia. The B cell crosses the this entire Sertoli cell. This entire Sertoli cell. This entire is again Sertoli cell. This will again have one spermatogonia. This will again give A cell and B cell. Right, A cell, B cell. A cell would regenerate. B cell would cross the Sertoli cell and cross the blood testis barrier. So we have something called blood testis barrier, right? So it crosses the blood testis barrier, and it is the B cell who is responsible for spermatogenesis. Okay, so it crosses the blood cell barrier first. Second, it comes into the lumen. So crossing the Sertoli cell comes into the lumen, and in the lumen it first gives to primary spermatocyte. So spermatogonium gives primary spermatocyte by mitosis. By mitosis it gives primary spermatocyte. The primary spermatocyte by meiosis 1, it gives 2 secondary spermatocyte. A secondary spermatocyte by meiosis 2 gives 4 spermatids. So this is the general process of spermatogenesis. Now here we can see 2n gives primary spermatocyte gives 2 cells, n and end. This is a tight junction. This is what? This is the spermatogonium. Yes, this is the spermatogonium. This spermatogonium that gives A cell and B cell. The B cell crosses. It's the B cell that crosses, and A cell again regenerates. A cell regenerates to give the spermatogonium again. This is the basal surface that we have marked here also. Basal surface. This is the basal surface. Right? Basal surface. Okay. Then we come to here. This is the flow chart representing this entire phenomena. So primary germ cells, we have seen primary germ cells enters testis, This line enters testis and becomes spermatogonia. Primary germ cell enters testis and becomes spermatogonia. So it becomes spermatogonia after entering the testis. This is what the lining of testis it enters. The lining of testis it enters. Then primary spermatocyte, this spermatogonia regenerates into A, B crosses tight junction that or the blood testis barrier or the blood testis barrier. Then it comes as primary spermatocyte. Does meiosis 1, secondary spermatocyte, meiosis 2. These are the spermatids. The spermatids give rise to, by spermiogenesis gives spermatozoa. Right, now another thing that is written in NCERT, another thing is that the spermatids leave the lumen of Leydig cells, I think, of Leydig cells by spermiation, by the process called spermiation. This is not Leydig, this is not Leydig, this is not Leydig, this is the Sertoli cells only. They are embedded in the head of the Sertoli cells, and they leave the Sertoli cells by the process called spermiation. They leave the Sertoli cells by the process called spermiation. What is the process called? The process called spermiation. Right? Okay. Next, we come to hormonal effect of spermatogenesis. The hormonal effect of spermatogenesis. This is the hypothalamus. The hypothalamus, via the hypothalamo-hypophyseal portal system, this hypothalamus sends neurons to the anterior pituitary. This is the posterior pituitary. Anterior pituitary is also called the adenohypophysis. The adenohypophysis of the anterior pituitary, and that is the posterior pituitary. Not required here. Posterior pituitary or the neurohypophysis. Right? The hypothalamus sends neurons to the anterior pituitary by the GnRH. GnRH is what? GnRH is gonadotropin releasing hormone. GnRH is a positive activator. It releases two hormones, that is LH and FSH. LH acts on Leydig cells, FSH acts on Sertoli cells. LH increases testosterone, and Sertoli cells, it helps in this positive feedback to spermiogenesis. That is this step, spermiogenesis. Then it releases inhibin and ABB. Now what does inhibin do? Inhibin sends negative signals. Inhibin sends negative signals to the FSH as well as the hypothalamus. The inhibin sends negative signals to FSH as well as the hypothalamus. That is a feedback control, feedback inhibition. It is a negative control, right? Feedback inhibition by inhibin. Testosterone also inhibits LH and hypothalamus. So testosterone also inhibits LH and hypothalamus. Then the testosterone along with ABP forms the ABP testosterone. It increases solubility, increases concentration. So testosterone along with ABP, what it does, solubility बढ़ाए and it also increases the concentration. Okay, next estrogen. Now we come to estrogen. Estrogen is also formed from testosterone by Sertoli cells. Estrogen, this is something out of the box. This is for Olympiads. This is not for this is for Olympiad. Any Olympiad. So what it does, testosterone also formed from testosterone by Sertoli cells. probably essential for spermatogenesis. The exact function is not known, but probably maybe essential for spermatogenesis. Now we come to structure of sperm. Okay, so the uppermost part is the acrosome. This is the nucleus. So sperm is first divided into head, middle piece and tail. Head, middle piece, tail. This is the acrosome. Then is this the nucleus, cytoplasm. This is the neck, body and mitochondria. Here we have the mitochondria. Mitochondria is there. So spermatid to spermatozoa, spermatogenesis. Okay, acrosome, nucleus, cytoplasm, neck, mitochondria, body. This is the tail. Okay, acrosome has Golgi apparatus, lysosomal enzymes, the hyaluronidase, proteolytic enzymes. They help sperm to enter the ovum. So acrosome helps sperm to enter the ovum. They have hyaluronidase, they have Golgi apparatus, they have proteolytic enzymes. Middle piece and tail. This is the middle piece or tail. First we come to middle piece and tail. They have 9+2 arrangement of the microtubules called axoneme, cell membrane covering axoneme. Function is motility of sperm from mitochondria of middle piece. Motility of sperm from mitochondria middle piece. Axoneme is there. Function middle piece and tail is mainly the function is motility. Mainly the function is motility. Right? Okay. Now functions of testosterone. It is also known as the male sex hormone, testosterone, produced maximum from the testosterone. Testosterone is also produced. Testosterone is also produced. From zona. We have if you remember the adrenal gland, it has the outer cortex, inner medulla. Outer cortex is further divided into 3 zones. They are zona glomerulosa, zona fasciculata and zona reticularis. So the zona reticularis sometimes also produces testosterone, small amount, but it produces testosterone. So for this one, zona reticularis of adrenal cortex. Zona reticularis of adrenal cortex. What happened to cortex? Okay. So males mainly from the testis, though. Androgens from Leydig cells. Now testosterone increase, abundant dihydroxytestosterone is also there, and androstenedione is also there. So androstenedione, dihydroxytestosterone, is also there from the Leydig cells, male sex hormone testis. Okay. Now testis in males it is about 300 to 1000 nanograms per dl. In females it is 30 to 70 nanogram per dl. Androgens, testis, major, adrenal cortex. This adrenal cortex 5% effect. So females, slight musculature, dust, pubic hair, axillary hair, and mainly it is steroid muscle. Now another function of testosterone is it has erythropoietic action. That means it also increases RBC count. RBC increases. Right? In tumor of adrenal cortex, androgen increase, female secondary sexual characters, adrenogenital syndrome. In tumor of adrenal cortex, androgen increase. Adrenal cortex, that means it is zona fasciculata. Yes, GFR. Sorry, it's reticularis. It's reticularis. Zona reticularis. So female secondary sexual character, adrenogenital syndrome. Secondary sexual character, that is growth of axial hair, then facial hair, axial hair, that is written here. Pubic hair, slight musculature. These in females. This will produce adrenogenital syndrome. That is it with the spermatogenesis. We'll come with oogenesis in the next video.